Unit 4, day 4 notes. It will probably help for you to have a unit circle handy for this stuff. The unit circle is quite important. We will be using it, this unit, and quite possibly every unit from here on. So make sure you're still practicing it. Make sure you're still committing this stuff to memory. If you need to take a screenshot of this, go ahead and do that. Or you can find your own copy. Now, something else that I did that will make today's stuff a little bit easier is I made a couple of brand new unit circle cheat sheets. This you do not have. You probably won't have anything like this given to you, but if you want to duplicate this on your own, you can. If you'd like to take a snapshot of that, please do it. I'm about to remove it in 5 seconds. Okay, and then here's another one, another little unit circle cheat sheet. All of this is what we'll be going over today. It will be explained when we get there. And if you want to take a screenshot of this one, please do. We're going to start off by doing a little bit of a review. If we needed to find the sine value at 30 degrees, we would go to our unit circle. Here's 30 degrees. Here's the sine value. If we needed to find the cosine value at negative 120, if you don't remember how to do those, remember, regular 120 degrees is here. That's where 120 degrees is. That means that from the x-axis, we would have to rotate 120 degrees to get there. So negative 120 means we have to go in the opposite direction. Negative 120 would be right about here. So this is where a rotation of negative 120 degrees is. What does it want? The cosine value. So that's negative 1/2. All right, tangent of 3 pi over 4. Here's 3 pi over 4. There's the tangent value. And then cosecant of negative 7 pi over 6. Well, here's 7 pi over 6. That is 210 degrees. So we need to do here's a positive 210 degree rotation. We need to do a negative 210 degree rotation. So that would be here. It wants the cosecant value. Cosecant is a reciprocal of sine. There's the sine value. And the reciprocal of 1/2 is 2. Right here, we're going to write the word function. Right here, 1, 2, 1. I think that by now we know what the vertical line test is. The vertical line test is how you're able to determine whether or not a function is indeed a function. As long as it does not cross your graph more than once, then it is a function. So this one is a function. This one over here would not be because we go through the graph once, we go through the graph twice. Now, the horizontal line test, here's what that does. The horizontal line test tells you whether or not you have a one-to-one function. So a one-to-one function is a function on its own and its inverse are both functions. So this one is not a one-to-one because this is a function, this is the inverse, but it's not. Now, one way you can tell whether or not a function is a one-to-one is the horizontal line test. If we did the horizontal line test, we'd cross once, we'd cross twice. Therefore, this is not a one-to-one function. Now, listen, if we were to restrict the domain of this function right here, this is what's really going to kind of tie in what we're about to do today and hopefully make it have a little bit, oh gosh, why can't I say this? Hopefully make it make a little more sense. Forgive me. If we restrict the domain, so the domain of this function is negative infinity, positive infinity. Well, if our domain is negative infinity, positive infinity, well then the reciprocal of that is not going to be a function. But if we restricted the domain, if we said, listen, our domain is going to be from 0 to infinity, well, then it would pass the horizontal line test it would create a function, an inverse function that would look like this. So therefore, we would then have a one-to-one function. So whenever we are going to graph our basic parent function of y equals sine of x, today we're also going to write its inverse. We're going to graph the inverse, y equals sine -1 of x. Well, in order for both of these to be a function, we're going to have to restrict the domain of this one so that this one will also be a function. We have a graph here. We're going to plot y equals sine of x. They have given us some x-intercepts, but we need to list what those values actually are. Pi over 2, pi, 3 pi over 2, 2 pi. Over here we have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. For our y values, we're going to have 1, 2, -1, -2. Now the parent function, the pattern, is middle, up, middle, down, middle. So right here, we have our top bumper. Here we have our lower bumper. And then right here, our midline. Okay, so let's start graphing. Middle, top, middle, bottom, middle. And then if we repeat that pattern going this way, middle, bottom, middle, top, middle, bottom, middle, top, middle, we can now connect. All right, so now, remember me telling you with this example here that this example, before we restricted the domain, it was not a one-to-one function. But once we restricted the domain, then it was a one-to-one function. Well, that's what we're going to have to do here, because this function would not pass the horizontal line test. It would cross once, twice, 3 times, 4. It would continue to cross into perpetuity. So we have to restrict the domain. We've got to figure out which domain can we use that its inverse will also be a function. That restriction is going to occur here. Right here. At negative pi over 2 to pi over 2. If we were to do the horizontal line test here, it would pass. Now, we need to remember here that now that since we've restricted the domain, our new domain is not negative infinity, positive infinity. It is negative pi over 2, comma, pi over 2. Our range is -1 to +1. Whenever we go to now graph the reciprocal, not the reciprocal, sorry, the inverse, y equals sine -1 of x, our domain and our range, they're going to switch. So our domain is now -1, 1. Our range is now negative pi over 2, pi over 2. And you see all of these x values here. These are going to be all of our y values now. So pi over 2, pi, 3 pi over 2, 2 pi. Our domain is -1 to 1. -1, 1. So what happens is our bumper's now vertical. Our midline is now here. All right, but remember, we have to use this restricted domain. So what I'm going to do is to kind of show you how we could graph this if you needed to, and you weren't quite certain, well, where do my points go now, is I've got to figure out what is this coordinate right here. Well, it's the x value is negative pi over 2. The y value would be negative 1. So we'd have to go left to negative pi over 2, down 1, we would now be at that coordinate. Here, that coordinate is 0, 0. This coordinate here, we have to go right pi over 2, up 1. Now remember, inverse functions simply flip. The values flip. So if I'm going to plot these values over here, the inverse, they're just going to switch roles. So it's negative 1, negative pi over 2, 0, 0, and 1 pi over 2. So now we could graph that. So negative 1, negative pi over 2, negative 1, negative pi over 2. 0, 0, 1 pi over 2, 1 pi over 2. And that is all we would want to graph, because by doing it this way, by not graphing any further, both of these are a function. So now we have a one-to-one function. All right, y equals cosine of x. Let's plot what our x-axis points are going to be. Pi over 2, pi, 3 pi over 2, and 2 pi. One, negative 1. That pattern for cosine is up, mid, down, mid, up. Now repeating that pattern from right to left. Up, mid, down, mid, up, mid, down, mid, up. Now we do not want to, once again, we're going to need to restrict the domain. But we don't want to use negative pi to pi over 2, because if we did the horizontal line test from negative pi to pi over 2, it would not pass. So this time we want to restrict our domain from this point to that point there. We're using x values here, so that is from 0 to pi. That range, once again, negative 1 to 1. And I will write down some of my values here so that we can find the inverse of them. So this point right here is 0, 1. This point here is pi over 2, 0. This point here is pi, negative 1. So whenever we go to graph our points over here, we want to make sure and invert them. So we're going to need to graph point 1, 0. 0, pi over 2. Negative 1, pi. Okay, our new domain for the inverse of cosine. That domain is going to be, remember, these are going to flip roles. Negative 1 to 1. The range is going to be 0 to pi. So domain, negative 1, 1. Range is from 0. This is pi over 2. This is pi. Now let's start plotting them. Might have to get rid of that dot there because we want to start at 1 comma 0. Then 0 comma pi over 2. Negative 1 comma pi. Now that we have restricted the domain, we have a one-to-one function. Tangent of x. Let me start labeling my intercepts here. And remember, this is that really wonky function that has asymptotes, vertical asymptotes at odd values of pi over 2. All right, our domain here, remember, we're going to restrict the domain. We want our domain to be from right here, from negative pi over 2 to pi over 2. But watch this. You're going to need to use parentheses here because we do not include the vertical asymptote. So parentheses, negative pi over 2, comma pi over 2, parentheses. Range. Doesn't that look like a cubic function? So that's going to be from negative infinity to positive infinity. So if we're now going to graph the inverse, let's flip these roles here. So our domain our range is going to be negative pi over 2, pi over 2. Okay, so since our range is going to be negative pi over 2 to pi over 2, this is our pi over 2 value. This is negative pi over 2. So rather than having vertical asymptotes like we did here, we're going to have horizontal asymptotes. And positive pi over 2, negative pi over 2. Then we can draw what looks like a cube root function. We have some new terminology here. The inverse of sine of x. Another way of saying that is arcsine. Another way of saying the inverse of cosine is arccosine. Arctangent. And here there is a misprint there. Don't worry about that. As we go through these notes, that will be explained, I assure you. Before we start filling in this stuff here, let me warn you. I wouldn't necessarily write down what I'm about to write down, unless you have something that you can erase with, because I'm going to show you something real quickly. If I were to say, draw a terminal ray with a 30-degree rotation, it'd look like that, right? What if I were to ask you to draw a terminal ray with a negative 30-degree rotation? You remember what that would look like? There, that is negative 30 degrees. We're going to have to use that same logic for what we're about to do now. What they want to know is, where does arcsine exist? In our quadrants, in our unit circles. Remember, we had to restrict the domain. Our domain was from negative pi over 2 to positive pi over 2. That's what we're going to have to consider when we're using these graphs here. So if I were to tell you, graph a terminal ray of pi over 2, that would be here. And that would actually be a quadrant angle. But what if I told you graph negative pi over 2? That would be here. Another quadrant angle. So it's almost as if we have a new unit circle that is just for arc sine. And that is where one of these cheat sheet comes in handy that I showed you a little bit earlier. Here, these are all of the values that you're going to need to know for arc sine. And it's almost the same thing. We still have our 30, 45, 60 degree angles. There they are in radians. We still have our 90-degree quadrant angle. They still have the exact same values. Just whenever we go this direction in quadrant 4, we're having to go in a negative rotation. So this is negative 30 degrees. This is negative 45. This is negative 60. This is negative 90. We still keep the same values. But remember, we're in quadrant 4, where the only thing that is positive is your cosine values. So if you'd like to now take a moment to pause the video and fill this portion in here, what I have there, feel free. Okay. Now, arc cosine. Where does arc cosine exist? I'm just going to write this down real quick. 1 and 4. This is where arc sine exists in quadrant 1 and 4. Arc cosine, what we need to remember is, well, where did we restrict the domain? We restricted the domain from 0 to pi. Now, this one is a little bit more straightforward. Here's the cheat sheet that we're going to use for arc cosine. It's from 0 to pi. So it's quadrants 1 and 2. There really is not much change here. So from 0 to pi, arc cosine exists only in quadrants 1 and 2. Feel free to pause the video now and write this information down. And now lastly, arc tangent. Where does arc tangent exist? We restrict the domain for arc tangent at negative pi over 2. You can't see it. Negative pi over 2, pi over 2. That's how we had to restrict the domain in order to have a function for arc tangent. So it's going to require the exact same cheat sheet as arc sine. Arc sine and arc tangent have the exact same modified unit circle. I would like to point out, however, that for arc tangent, it does not include pi over 2. Because remember, those were the asymptotes were. So it will not include that value. It's going to include up to that value, but not that value. And it is not going to include negative pi over 2. Not. But that is where arc tangent exists. Okay, let's look at example 5. Now they want us to compare the difference. So for this unit, they said, hey, sine of what angles will produce 1/2? So here is a sine value of positive 1/2. Here's another sine value of positive 1/2. So whether you want to think of it in radians or degrees, we could put 30 degrees. We could put 150 degrees. Or you could use radians. It doesn't really specify here. Let's just stick with degrees. Now let's find the difference. Where does arc sine of 1/2 exist? Well, we don't really want to use this unit circle necessarily. You would need to use your modified unit circle. Here's our modified unit circle for arc sine and arc tan. So our sine value of arc sine that is going to produce 1/2 only exists here at 30 degrees. So I think a pretty obvious difference here is that if we're working these problems out like this, sine of what angle equals a particular value, you will have two answers if it's not the inverse. If it is the inverse, you're only going to have one answer. Okay, let's go ahead and skip over to the back where we have a little bit more room to work. Find the degree measure for the problems below. Arc cosine. So we want to use our arc cosine cheat sheet here. We do this a little better. So arc cosine of root 2 over 2. We're just trying to figure out which cosine value has positive root 2 over 2. There it is. That's the only one. So 45 degrees. Now arc sine of negative root 3 over 2. So we don't need the arc cosine cheat sheet. We need the arc sine cheat sheet. We need to locate the sine value of negative root 3 over 2. There it is. Right there. And that is a negative 60-degree rotation. They want us to find the degree and radian measure here. So sine or arc sine of negative 1. We already have our arc sine cheat sheet. Let me scoop this up a little bit. Do you know why? Because arc sine negative 1 is there. That's a negative 90-degree rotation. They also want it in radians or negative pi over 2. 14, let's find arc cosine. So arc cosine, we need our arc cosine cheat sheet now. Arc cosine of root 3 over 2. So we're looking for the cosine value, positive root 3 over 2. There it is. That's a 30-degree rotation over pi over 6. Radians. Okay, tangent, arc tangent of negative root 3. So let's get our arc tangent cheat sheet here. Let's figure out where negative root 3 is. There's positive root 3. There's negative root 3. That is a negative 60-degree rotation, negative pi over 3 radians. (16) Arc sine. We already have our arc sine cheat sheet here of negative root 2 over 2. Sine value of negative root 2 over 2. There it is. Negative 45-degree rotation or negative pi over 4 radians. Okay, sine, arc sine of root 3 over 2. I'm looking for the sine value that has root 3 over 2. There it is. That's 60 degrees or pi over 3. Arc sine of negative 1. Still using the arc sine cheat sheet. Right here. That's the sine value at negative 1. So that is negative 90 degrees or negative pi over 2 radians. Number 19, arc sine of negative 1/2. So which sine value is negative 1/2? There it is. Now, arc sine of negative root 3 over 2. There's negative root 3 over 2. There's our answers right there. Arc sine of 0. There's where sine is 0 right there. Okay, example 22. Look carefully. Look carefully for to see. I don't think that really makes sense, but I think you know what they're trying to say. Look out. They're just trying to make you aware of the fact that they might be changing it up a little bit, and they are. So cosine of pi over 6, what they're wanting to know is what is the cosine value at pi over 6? So we need the good old unit circle. Here's pi over 6. There's the cosine value. What is the cosine value at 7 pi over 4? There's 7 pi over 4. And there's the cosine value. What is the cosine value at negative 2 pi over 3? Well, here's 2 pi over 3, regular 2 pi over 3. That's a 120-degree rotation. So we need to do a negative 120-degree rotation. There. I think it wanted another cosine value. It did, which is here. Okay, now arc cosine of 1. Okay, we need that arc cosine cheat sheet again. So we're trying to figure out is where is cosine 1? There it is. That's at 0 radians. Arc cosine of root 3 over 2. Right there. Arc cosine of negative 1/2. So where is cosine negative 1/2? Right there. That's at 2 pi over 3 radians. Cosine of negative 5 pi over 6. Well, I don't see any arc or inverse there. So we want to go back to the original unit circle. Negative 5 pi over 6. Well, there's regular 5 pi over 6. That is a 150-degree rotation. So we need to do a negative 150-degree rotation, which would put us there. Cosine value is negative root 3 over 2. Arc cosine of negative root 3 over 2. Where's our cosine value of negative root 3 over 2? There it is. That's at 5 pi over 6 radians. Example 30. Arc cosine of negative root 2 over 2. 3 pi over 4 radians. Okay, let's look for some others that are a little different. We haven't really done a lot of tangent ones, have you? Let's just go ahead and skip down here. Okay, tangent of 3 pi over 4. Since that is not an inverse, we need the original unit circle. 3 pi over 4 is here. That tangent value is negative 1. Tangent of 2 pi over 3. There's 2 pi over 3. There's the tangent value. Tangent of 11 pi over 6. There's 11 pi over 6. There's the tangent value. Arc tangent of root 3. I have the wrong cheat sheet here, don't I? We need this one. That's our arc sine and arc tangent cheat sheet. So I need to find the tangent value of root 3, which would be there. That angle is pi over 3 radians. Arc tangent of negative 1. So where's the tangent value negative 1? There. That's at negative pi over 4 radians. Arc tangent of negative 1. We already did that one. We just did it here. Arctangent of negative root 3. So which tangency has a value of negative root 3? Right there. That's at negative pi over 3 radians. And then arctangent of 0. Which one of these angles has a tangency of 0? That's going to be here. That's at 0 radians. There you go.